Hi guys, welcome back to my channel Pirai Academy. Today we are going to see about a question called minimum operation to make it as a permutation. So this is the question that is asked in Turing. Fine. So in this question they will be given an array and we want to say them how many minimum number of operations required to make that array of 1 to n permutation. Okay, in one operation you can either plus 1 to any element or minus 1 to any element, which means, for example, see this first example, it is 2 1 3 4. It is one of the permutation of 1 to n. Okay, first of all, what is mean by permutation? Many don't know about the permutation, right? So what is mean by permutation? So permutation of, say for example, 1 2 3 can be said as 1 3 2 or 2 3 1, which means what are all the different possible arrangements of these all integers in that array is called permutations. Okay, totally we have a permutation of, for this there are totally 6 permutation. For any n value we have n factorial of permutations. Hope you understand this. Okay, so this is the whole definition of permutation. Now see here, this is one of the permutation of 1 2 3 4, right? In the question itself they have clearly stated that we want to just make that given array to 1 to n permutation. Okay, see here it is 1 to n permutation because the length of this array is 4, right? So 1 to 4. So whether it is 1 to 4 permutation, is it is 1 to 4 permutation. Okay, so what is my output? It will be 0 because I don't need any operation. I don't want to increment or decrement any elements in the array. Okay, it is already in the permutation, so no worries. So our output will be 0. Similarly, see here it is 4 1 4 2. Fine, the output will be 1. How? Because if I just make this 3 or if I leave it and make this as 3, any one of them, okay, then it will be of permutation of 1 to 4. Can you understand this? Yes. So in one operation, okay, you can either increment one element or you can either decrement one element by 1. Okay, that's given in the question itself. Fine. So how to do this, or how to derive a logic behind this? Fine. So this is basically a greedy problem. Why I'm telling you that it is basically a greedy problem is, see here, we are just given that it is conformly it will be 1 to n permutation. Yes, which means for 3 elements we only have the array elements as 1 2 3. For 5 elements, 5 size of array, it will be 1 2 3 4 and 5. Can you understand this? So it is basically like we want to find how many times the operation should be done in the each and every elements to attain this values. Okay, so for example, if I take this second example, okay, it will be 4 1 4 and 2, right? Now just look at this carefully. Here this 1 is present, so no worries. Now this 2 is also present, no worries, but there is no 3, right? So I want to either change this 4 into 3 or else this 4 into 3. Okay, for example, if instead of this 4, if I have a 5, then tell me what of if for example it is maybe a 6. Okay, it is maybe 6. So 1 is finished, 2 is finished. Now for 3, whether I will be adding only 1 to this 4 or I want to make this 3 into this 6. Can you understand this? So it is basically like we will be sorting the given array. Okay, then we will be finding the difference between them. Like for example, if I take this array itself, then I will be sorting it. If I sort this array, it will be 1 2 then 4 then 6. Yes, now I will be just iterating over them and I will be checking whether this first element is equal to 1. Yes, the second element is equal to 2. Yes, the third element is equal to 3. No, then I will be doing 4 minus 3, the absolute value. Can you understand this? Yes. So which is equal to what? Which is equal to 1. So you need only one operation to change this 4 into 3. What is that operation? It will be decrease by 1. Can you understand this? Now here comes 6. So absolute of 6 minus 3, which is equal to 3. Okay. So here I need 3 operation to make this. Sorry, here comes 4, right? Sorry. So here comes 2. So I need 2 operation, 2 decrement operation in the 6 to make this as 4. Okay. Can you understand this? Yes. Okay. For another example, I will be taking another value. After sorting that array, the array something looks like this. Okay. Fine. Now here is 1, here is 2, here is what? Not equal to 3, right? So 2 minus 3, take the absolute value, which is equal to 1. Now hope you understand why we are taking the absolute value. It can be greater, it may be lesser. Okay, that's why we are taking the absolute value, which means I want only the difference regardless of what is the sign behind it. Okay, so it is 1. Now here comes 3. So absolute of 3 minus 4, which is equal to 1. So I have to add 1 to this 2 so that it will be 3, and I want to add 1 to this 3 so that it will be 4. Can you understand this? So what is the algorithm, or what are all the steps I want to do? I want to sort the given array first. Okay, and then I want to iterate over I want to iterate over 1 to n, and I want to take the absolute difference of this 1 to n with the array element. Okay, I want to take the absolute difference, and just add it into the result. At last I will be returning the result. That's it. Can you understand this? Yes, because see here it is 1. Okay, and 1. So 1 minus 1 is equal to 0. Anyhow, adding the 0 will not affect our answer. Can you understand this? Okay, fine. Now tell me, what is the time complexity? The time complexity will be O of n log n, because I am using a merge sort algorithm to just sort this value. Yes, and then what is the space complexity? It will be O of n, because I will be using the merge sort algorithm that takes the auxiliary space also. And the time complexity will be n log n plus n, because I am again traversing this whole array, but approximately it will be equal to n log n only. Okay, so still someone or sometime we will be having a doubt why we are sorting this, right? Because instead of checking like whether this 1 is present in this array, or this 2 is present in this array, or 3 is present in this array, instead of checking like that, if I sort this at first, then checking it will be quite simple. That's why I am sorting this, so that it will be the optimized solution. If I don't sort it and I will be going one by one, okay, then the time complexity will be of n square. That's why I am not going with that n square approach. I am going with the optimized approach. Since in Turing they will be giving a test case that's run up to, like, for this they will be giving a test case of 10 power maybe 5. Okay, 10 power 5 or 10 power 6. So that for this 10 power 5, if I go with the n square approach, then it will be 10 power 10, which is greater than 10 power 9 the clock time. Okay, then it will be showing the TLE. Hope you understand this. Okay, that's why I'm going with this approach of sorting the array first, then I am just finding the difference next. So let us see the question, see the code. So in Turing they will be preferring a Python code. Okay, first of all I will be sorting it, then I will be taking the operation as 0, the resultant. Okay, and then I am traversing the given array which is sorted in our this coding path. Okay, now operation plus is equal to absolute difference of a of I minus I plus 1, because I is starting from 0, but we need a starting from 1. That's why I am doing a I plus 1. Now at last return operation. That's it. So if I run this, you can see the output is this. Hope you understand this. If you really like this video and subscribe to my channel. Don't skip any videos in this playlist, because all videos will be helpful once you are appearing for the interviews. And if you have any doubts, you can post in the comment section. I'll be clearing the doubts in the comment section, or I'll be putting a separate video also. And you can go and explore much more algorithms on greedy or backtracking in my YouTube channel. Thank you.